Hey everyone, and welcome to the start of a new unit. And, components to this unit are going to feel familiar, but then pretty quickly it's going to charter into unnavigated territories. So just wanted to kind of highlight the fact that our warm-up here is something that we should be able to succeed with without any kind of additional instruction. This is really review of trig and special right triangles, which is going to be super important to this unit. So the unit itself is going to be on trig functions. So as much as we've talked about sine, cosine, and tangent, we've really looked at them in a pretty limited capacity, which is just finding missing angles or finding missing sides in right triangles. And really, they have tons and tons of applications. So the first kind of page here and then even the top question, ideally is a warm-up. Otherwise, what I would have you do is kind of check your work. The completed notes will be up, so kind of check your work, but also in this video you might be able to kind of pause it as you go down. But the first thing that you had to do was label your sides in this special right triangle. And then here, for the trig functions component to this I would, highlight, no pun intended, that the exact answers that we should be going for are highlighted here in kind of this off orange color. So we should be able to all simplify down and get the exact same results by either rationalizing the denominator or just simplifying the fraction. This is what we should have. So if somebody kind of came up to you and said, hey, what's the tangent of 60 degrees? Then we know that it's the square root of 3. We don't need a calculator anymore. So we get kind of these freebies almost that we should be able to come up with. And they all stem from special right triangles. So we've got those, and then we're going to be using some other angles throughout the unit. But also, kind of our big launching off point today is realizing that there are other ways to measure angles. So I'm going to skip over this kind of top part. You can read it on the finished notes if you'd like. But otherwise, I'm going to hop right into this, which is the introduction to radians. So this is big. You've probably grown up always looking at angles as, 360 degrees if somebody does a full turn. But really, mathematically, one of the more powerful tools, I would say, is to not use degrees to measure angles, but instead to use radians. So a radian, in kind of the most, introductory way, is the angle formed when a radius is wrapped around the outside of a circle. So, in a circle, we have 360 degrees, right? But if I took that radius, which is, this little red line right here, and then I just kind of molded it around, or I started to mold it around this circle, I'd be able to get a certain distance, okay? So I'll just kind of say there. And then this angle right here that I was able to form, this is going to be 1 radian, okay? I will say, and this isn't super helpful or knowledgeable, but I know that mathematically as I was going through this, I was like, what is that? So it ends up being like 57.29 degrees, I believe. Let me just kind of do a quick check here. But because again, it's not like super useful knowledge, because we have kind of ways of dealing with that outside of it. So it ends up being like 57.29 degrees. But this is an approximation, so I wouldn't count on it. It's just visually that's what it ends up being. Okay? And then the reason why this is beneficial is it's going to start making sense to us that, if I kept going here, then I can go a little bit further. So now this would be 2 radians that I was able to get around. And then, let's see, I kind of want this to look like this. So now that would be 3 radians that I was able to get around. I want this to be a unique color, sorry folks. And just notice that we're kind of 1 step short So this would be 1 radians, 2 radians, 3 radians, or this little bit off, right? And for those of us that are kind of thinking about this, and we know how many times a radian goes around a circle, or how many times it's going to go around half a circle. So the circumference of a circle is 2 pi r, or 2 pi times the radius. So it takes 2 pi radians to get around the circle. So here, this, this little distance that I'm end up being off, is that remainder on pi that I end up being off. So if I have something that's 180 degrees, I can also just say that that is pi radians. Okay? So how many radians or radii does it take to go all the way around the circle? It takes 2 pi of those. So 2 pi is our full 360 degrees. So somebody says, well, okay, convert 360 degrees to radians. We just say it's 2 pi. That's just how we pronounce it. So it doesn't have another thing like, you don't have to say degrees after it or anything like that. In fact, if someone's talking about an angle and it's missing degrees, then they're probably talking about radians. So halfway around a circle, we did cover that. So to go halfway around a circle, if I was wrapping those radiuses, would be pi, which is 180 degrees. So those kind of convert back and forth. A quarter of the way around the circle, well, that's just going to be half of pi, or half of halfway around the circle. So I'm going to say pi divided by 2 gives me 90 degrees. All right? So converting back and forth like this, it becomes a little bit more difficult if I say something like, well, okay, what's 74 degrees? So we're going to need a better system than just trying to chop up a circle perfectly in order to convert between the two. But this kind of gives us the visual understanding of what we call it. And, lots of power behind calling this a radian. And it, 360 is very arbitrary. Whereas if somebody says, oh, it's 2 pi, it makes a lot more sense because that's the entire distance. That's how many radiuses it takes to get around a circle. So that's why we like measuring angles mathematically using radians. So I'm going to show you a quick kind of conversion strategy here that I call train tracks. I'm not sure if it's been done at South Burlington before, or if other teachers teach on this same thing, but it's definitely kind of helped me out. So if I have to do some kind of a conversion from days into minutes as an example, I would start off with 65 days, and then I create kind of this system of train tracks, which is going to help me convert, get closer and closer to minutes. So I probably need to go from days to hours into minutes. So 65 days, I want to convert away from days. Well, I know that 1 day then has 24 hours. And the reason why I wrote it like this is so that my days can cross out here. Now you'll see that I'm kind of left in hours, and I want to convert away from that. Well, I know that 1 hour then has 60 minutes. Cross those out. And now I'm at the unit that I wanted to be in. So what I end up doing is multiply everything on top together. So that's 65 times 24 times 60. And I got 93,600. Multiply everything on the bottom together, which is just 1. So my answer here is 93,600 minutes. Okay? And we're going to use this same kind of conversion strategy in a second in order to convert radians to degrees. But I wanted to show you that it's really no different from any other kind of conversion strategy here. All right, convert 0.45 miles into inches, so I probably need to go miles to feet to inches. So I'm going to start with what I know, 0.45 miles, and then just use conversion strategies in order to figure out the rest of it. So I know that in 1 mile, there's 5,280 feet. And then I also know, so miles is now gone, so now I'm in feet, and I know that in 1 foot, that there's 12 inches. Can cross those off. And I'm in a similar strategy where I just need to multiply everything across the top. Multiply everything on the bottom, which is just going to give me this. So 28512 inches. And the reason I like this strategy is because you should be able to look down on a bunch of just very easy, knowledgeable conversions that you can look up. And it keeps track of your units along the way, and it can handle like more complex conversions than these. So maybe we'll do some examples in class as well, just because very useful tool to have. So here, if I have to convert from radians to degrees or degrees to radians, so let's just say, I'm going to give us 5 pi, and I want to convert from radians to degrees. So 5 pi, and that's in radians, right? It doesn't have a degree notation on it, so we can assume that it's in radians. And the one thing that I need is that conversion between the two. And the one that I like most is to say, okay, I know that pi radians, and I can put a little rad down here just to kind of remind myself that it's in radians, is 180 degrees. Okay, so then if I look to kind of cross all this off, that's a little bit strong. I can see that I'm in degrees, so my radians are going to cross out. And I also notice here that, in this conversion, it's nice that my pi is also going to cancel out. So I just have 5 times 180. So I get 900 degrees. And you can kind of work this out for yourself, but 5 pi should be 5 half rotations of a circle. So that'd be 2 full circles plus another half. So 360 to 720, and then plus another 180 gives me 900. So it works out. So this is degrees to radians. So let's say I have 320 degrees, and I want to convert to radians. My difference here, just kind of the switch here, is that I'm going to put 180 degrees on bottom because that's what I want to get rid of. And I can put pi rad here again, not super commonly written like that. You can just leave it as pi if you want, but I'm going to put it in here just for kind of transparency. My units cross out, so I end up here. I could even go so far as to cross out, these zeros just in an attempt to try to simplify this at this point. So I'm left with 32 pi over 18. And then I do want to simplify that, so I can get down to 16 pi over 9. And then that appears to be basically as far as we can go. So 16 pi over 9 radians is, what we would leave this as. That's kind of our final answer. So here we're just kind of proving something that we already have. Convert 360 degrees to radians. Another strategy, and just kind of the shortcut of it, is if I'm doing degrees to radians, so degrees to radians, I want to multiply by pi over 180. And if I'm going radians to degrees, then I multiply by 180 over pi. I like the train track strategy because you don't really need to think about which one you need to, is it flipped or is it this? We just say, okay, if I need to get rid of degrees, then I need degrees to go in the bottom. Okay, so in my mind, it expedites this process a little bit. So I'm left with 360 pi over 180, which simplifies down. I can just get 2 pi from there. All right, so that's kind of the proof of it. So here what you're going to do, convert these following the 30, 60, 90 to radians using any strategy really of your choice, and then we're going to put them on the table on the front, just because that's something that we're going to refer back to. And what we should be able to say now is, oh, instead of sine of 90 degrees, I also want to know that the sine of pi over 2 is also going to be this same value that I found on that table. So try to complete those, and then you can complete it. The finished notes will be on Neo for you. Finally, what you're going to be doing is converting, or actually this is where I was kind of hoping you would evaluate these. Let's see. Yeah, we should be able to evaluate all of these, and maybe I'll just kind of show you one, but you should be able to evaluate all those once you have your table. And then the last piece of today's lesson is you're converting back and forth on here and trying to figure out, maybe some of these trickier ones down here where you'd probably want to convert to degrees first and then plug that into your calculator. If you have a fancy calculator, you can do it all at once if you know how to mode switch to radians, but I'll show you that in class as well. All right, thanks everybody.